Hi, everybody. So I'm sorry I couldn't be with you guys again today. It's my second day to work on IEPs, but I promise after today I will be back. So what we're going to talk about today is something called compound interest. It is a continuation of what we were just working on last week. I know last week, probably by the end of the week, we were all like, all right, I'm all tired of doing interest. We've done it so many times, but practice makes perfect. And I do feel like you guys are starting to memorize your interest formula. You're remembering how to convert a percent to a decimal. You know how to round. We did so many good practice skills last week. So I'm very happy with, I feel like, how we're progressing. So what I want to talk about today is compound interest. This can be a very tricky subject. I kept today's lesson very straightforward and very simple. It could be harder, but I'm going to be nice to you guys and not make it very hard for now. So what I want to start out by doing is kind of explaining what compound interest is, because it can be a tricky subject. I actually taught it in my old school last year, and those 11th graders did not like the topic very much either. It could be a little bit challenging. So I'm going to kind of try to explain it to you the best way that I know how. So I'll give you the formal definition, but then I'm going to explain it in a different way. So with compound interest, you're not just earning interest on your original balance. Compound interest is when you add the earned interest back into your original balance, which then will earn you even more interest. So this is how I kind of want you guys to think about it. I want you to think of it as like a snowball effect. So picture right now a tiny snowball on the top of a hill. And that snowball is going to start falling down the snowy hill. And as it goes down the hill, it's going to start to collect more and more snow, right? Like if you've ever built a snowman before, you roll it in the snow and it picks up more snow, so the snowball gets bigger and bigger and bigger. So that's basically what's happening in your savings account. So as a quick little review of what interest is, when we put money in a savings account, the bank pays us for doing that. So we're earning interest. So you put money in, let's say you put $1,000 in, and then you will earn interest. So over a certain amount of time, you're going to start earning money on top of that $1,000. So here's a little example that might make it easier for you to understand. So let's say you open a bank account and you decide, I'm going to put $1,000 in my savings account. And every bank is slightly different. What's happening to my stylus? Oh, there we go. Okay. So you're starting with $1,000 and you put that in your savings account. You know it's going to earn interest. In this example, we'll say that it earns 5% interest. So after 1 year, you actually earn $50 in interest. How great. You earned $50 in a year. So now we have $1,050. So we just went up. We went from $1,000 to $1,050. Then what's going to happen is the next year is going to come around and it looks like you're earning an extra $5,250, which now leaves you with this much money, $1,102. So do you see how your amount here is like the snowball? So you start with $1,000, then it starts rolling down the hill. It picks up interest. Now you're at $1,050. It's going to keep rolling down the hill. It's going to get bigger and bigger. Now we're at $1,102.50. So that's what compound interest is. Your money is going to keep growing and growing and growing because it's earning interest by staying in a savings account. And if you notice, when we started with $1,000, we made $50 in interest. Then when we started with $1,050, we earned $5,250 in interest. So the bigger or the more money you have in your account, the more interest you're going to earn. So every time you go up, the interest is going to increase. Now, 50 and 5250, they're not that far apart. So I didn't earn that much more, but I'm still earning more. And that's only going to get bigger and bigger as we keep going. All right, so that's kind of what I want you to understand for today, is that compound interest is like a snowball effect. The money in your account is going to keep growing and growing and growing. All right, now before we actually do a problem, and I promise the problems today are not too bad, there is something that I want us to just remember. So prior to this, when we were doing our interest problems, I told you need to look for either the word monthly or the word daily, because that will affect your time. Remember, T in the interest formula, I equals P times R times T. T stands for time. So when we put our time, we always write it as a fraction. And the number in the denominator, the number down here, all depends on which term they put in the word problem. So if they say monthly, We remember that means that our denominator is going to be 12. If you see daily, you got to think, how many days are in a year? 365. Now, I'm going to teach you a new one today. There are actually a bunch, but I'm just going to teach you another one today. It's quarterly. So in the first one, monthly, we think to ourselves, how many months are in a year? Then for daily, we think, okay, how many days are in a year? Now this one's quarterly. How many quarters are there in a year? Well, that's kind of weird. Maybe you've never heard of that before. This is how I like to think of it. How many quarters are in a dollar? So how many quarters do I need to get to $1? So here's one quarter, that's 25 cents. Here's another quarter, that's 50 cents. Here's a third quarter, that's 75 cents. And here's our fourth quarter, that's $1. So there are 4 quarters in a dollar, and there are 4 quarters in a year. That's a little way to remember it. So when we hear quarterly, we're going to think 4. We don't have to put this one on top if we don't want right now. We don't know what's on top as of right now, so we're just going to leave it. I'm sorry, this keeps erasing. Here we go. All right, so some number is going to go on top of the fraction. We don't know what that number is right now, but the most important is what goes on the bottom. So monthly is 12, daily is 365, and now our new term today is quarterly, which is 4. There are 4 quarters in a year. All right, so let's get started. So there will be a new formula for us today on how to calculate compound interest. So our new formula for compound interest is going to be our new balance minus our original principal. Okay, what that's going to give us is our compound interest, so it equals compound interest. So the part that I need you to remember is, after I finish writing this, I'm sorry, compound interest. I know I'm writing a little sloppy today. I've been using a new pen to write on my iPad, and it's a little hard to write with. So new balance, so whatever we have at the very end, minus what we started with. That's going to tell us how much interest we earned as we went down our hill, our snow hill, right? We're thinking about it like a snowball effect. So this is going to tell us how much interest we earned. We're going to take whatever we have now and we're going to subtract what we started with. That will tell us, okay? That's the form you're going to need to know today. So let's take a look. We're going to do an example. I'm going to kind of help you through this one, and then you guys can help me with the rest. So a lot of words, but very simple, quick formula. So not a lot of math, which I know you guys will be happy about. So first one, Jamal deposited $1,800 in a savings account, which earns 6% interest that is compounded quarterly. Here's that word. So 4 times a year, Jamal is going to make money on interest. After quarter 1, Jamal had $1,827 in his account. After quarter 2, Jamal had $1,854.41 in his account. What is the compound interest? So basically what I want to know is if Jamal started with $1,800, and then a quarter later, he now had $1,827 in his account. And then a quarter later, he now had $1,854.41 in his account. So what is the compound interest? So as soon as I see what it's asking for, I need to write down my formula. So compound interest is equal to our new balance. Oop, a little sloppy there, sorry. New balance minus our original principal. So our new balance is whatever we are currently at. So the very last amount that you see in this word problem is your new balance. So how much does Jamal have now after we've already been through quarter 1 and through quarter 2? So Jamal now, at the very end of the sentence, you see he is now at $1,854.41. So that's his new balance. His original principal, well, you guys tell me, how much did Jamal start with? What was the first amount he put into his savings account at the very beginning? Hopefully you can see, it says it in the first sentence, Jamal deposited, he started with $1,800. All right, so we have some subtracting to do. I'm going to quickly do it on the side here. I have 1,854.41, and I'm subtracting 1,800. So the amount that I ended up with was $54.41. So that's how much interest Jamal earned after 2 quarters. Now, this was only after 2 quarters. Quarterly, there are 4 quarters in a year. So I could have in this problem given you the amount in quarter 3 and then given you the amount in quarter 4. And we could have figured out how much compound interest he earned over 4 quarters. And this one, we only went over 2 quarters. Doesn't really make a difference for the problem. It's just all depending on what it's asking. Okay, so very simple formula, not much to do here, not much math. The other problems we were doing had way more math involved. So hopefully you don't feel as stressed out about these ones. All right, so let's try another now that we know how to do it. Jeremiah deposited $900 in a savings account that earns 6% interest compounded quarterly. So basically the same as before. After quarter 1, Jeremiah had $913.50 in his account. After quarter 2, Jeremiah had $927.20. What is the compound interest? So here we go again with that question. We know how to do it. We have to look back at our formula. Compound interest is equal to our new balance minus our original principal. All right, so new balance. So how much money does Jeremiah have currently? So after he earned interest not once but twice, how much does Jeremiah have now at the very end? So you should look at the very end, the last sentence of this word problem. That will tell you how much money Jeremiah has. So he has, if you see it, $927.20. So I'm going to fill that in for the new balance. But before I do that, let's look for the original payment because I also need to plug that in. So how much did Jeremiah start with? So he ended with $927.20. He started with $900. So there we go. $927.20 minus $900. All right, so that is going to give me $27.20. There we go. So Jeremiah over 2 quarters earned $27. Now take a look real quick. Up here, Jamal earned more than Jeremiah. And why is that the case? Well, it's because if whoever puts more money in to start with is going to make more interest. Jamal put in 1,800. Jeremiah put in 900. So Jamal put in more than Jeremiah. So Jamal's going to make more interest than Jeremiah is. Okay, so the more money you put in, the more interest you're going to earn. Also has to do with our percentage, but if you look, they actually had the same percent. So that didn't change anything. All right, let's give it another go. Number 2, Ashley deposited $18,260 in a savings account, which earns 2.5% interest compounded quarterly. After quarter 1, Ashley had $18,374.13 in her account. After quarter 2, Ashley had $18,488.97. What is the compound interest? All right, formula real quick is new balance minus original principal All right, new balance. So what does Ashley have at the very end? What is she currently at? So I always say, look at the very end of the whole paragraph. It's going to tell you at the very end. After quarter 2, this is how much she had, $18,488.97. That's where she's at currently. But originally, where she originally started was $18,260. So she made a decent amount of money on her interest. So let's plug those in. So $18,488.97 minus $18,260. All right, I'm going to my calculator. 18,488.97, and I'm subtracting 18,260. And I actually earned a lot. Ashley here earned a lot because look how much money she started with. She started with $18,000. That's a lot of money. So she's earning a lot of interest. She's earning $228.97. Crazy. She earned a lot of interest for doing nothing. All she did was put money in her account. Now, I'm not saying it did not take her a while to get all this money, right? She's got to start somewhere. She must have worked really hard to make all that money. But by putting it in a savings account instead of her checkings, she's going to earn money. Okay, very nice. Last one. This one we are going to have to do a little bit of extra work. You didn't think I was going to let you off so easy. So last one. Alicia's savings account has a principal of $1,200. It earns 6% interest compounded quarterly. After quarter one, she had $1,218. What is the amount in the account after quarter two? Okay, so the difference between this problem and the ones before is they gave us how much she makes after quarter two. And this one, we have to figure it out. We have to do the math. So the only way to figure out how much interest she's earning is by using our interest formula from last week. So very quickly, I'm going to write this down to get us started. How much interest in quarter two? So we need our formula. P times R times T. All right, let's start with principal. So how much money does Alicia have? But now this is where you have to be very careful. P, principal, you're all going to say, oh, principal right here. Principal is $1,200. Careful. That's how much she had before quarter one. But after quarter one, she had $1,218. So we don't need the old amount anymore. We need the new amount. That's what our current principal is. So her current principal is $1,218. All right. So now we're going to look at the rate. So what is the percentage? The percentage is 6%, but we know we can't write that as a percentage. We need to convert it. So we need to move the decimal once, twice, and fill in a 0. So we're using 0.06 as our R. Our time, here's where this comes in handy. Quarterly. There's no monthly and there's no daily in here. So I'm going to write it over here. Our denominator needs to be the number 4. Okay, so we're looking at just quarter two. So that's just another quarter. So quarter one, quarter two, if there's quarter three and quarter four. So our numerator is actually just going to be 1 because we're just referring to one quarter right now. It's not quarter one, but it's just one quarter. One quarter out of 4. So we could leave it as a fraction, but like I told you guys, calculators are a little messy sometimes with fractions. So I'm going to turn this into a decimal by dividing 1 divided by 4. And that's equal to 0.25. So there we go. That's our time, 0.25. So I'm going to use all of these numbers, throw them in my calculator. So 1,218 times 0.06 times 0.25. All right, so Alicia in quarter two earned $18.27. But the question wants to know, what is the amount in the account after quarter two? So she earned $18.27, but I need to know, so once I take that $18.27, I need to add it to the original principal. Not the original, I'm sorry, the principal that we are currently at. So right now, she has $1,218 in her account, right? That's how much she has. But she just earned $18.27. So she now has $1,236.27. Okay, so we just did all the work that these problems gave us. They gave it to us. Here, they did not. We have to do some of the work. But the nice thing is you guys already know how to do this because we did this last week. So now we can finally finish. What is the compound interest? This is the easier formula. Okay, so here I'm going to write my formula down one more time. New balance minus original principal. And then we'll be done. New balance was, well, we just found the new balance. 1,000 $236.27. That's how much Alicia has now. But her original principal, where she started with, is all the way up here in the first sentence. She's a principal of $1,200. That's how much she started with. And we can finally figure out how much compound interest she earned. So I'm going to quickly do this math. Oh. And here we go. $36.27. And there we go. We're done. We figured it out. All right. So a little tricky, this last problem. I'm going to star it because it was very tricky and I wasn't expecting everyone to be perfect today. But what I do want you to take away from today's lesson is our new formula. So new balance minus original principal. And I wanted you to have an understanding of what compound interest is. So tomorrow when we talk about it, I want you guys to remember the snowball effect and thinking that our money that we start with is like our little snowball. And as time goes on and we start earning interest, that snowball or our amount of money is getting bigger and bigger and bigger and bigger. Okay? So I'm going to stop there. Thank you for powering through today with me, even though I wasn't there with you guys today. Hopefully you were able to answer some of the questions. And I will see you guys tomorrow. All right, bye everybody.